Welcome back everyone, Patrick here, moving on to another word problem. This is a pretty popular word problem dealing with quadratics. So a concert currently sells $18 tickets to 120 people. And then for every $1 increase in price, 12 less people will go. And also vice versa. So if we decrease the price by $1, then 12 more people will go. So it works both ways. And given that scenario, what we have to do, part A, create a revenue equation. Then in part B, we have to describe what all the intercepts mean of that equation. Part C, when is the revenue maximized? And then part D, we have to sketch a graph of the relation. So to start off, let me just go over quickly what revenue is in general. We know that revenue, just for anything, is equal to what? The number of items sold, or the number of products sold, times the price per item. Right? No matter what you're selling, the number of those items that you sell times the price per item, that's going to give you your revenue. So in this case, we're dealing with a concert that's selling tickets. So right now, currently, they are selling $18 tickets to 120 people. So the number of tickets sold is 120, and then the price per ticket is $18. So the current revenue that this concert is generating, if we multiply these, is $2,160, right? That's the total revenue that's being generated. Now, we're told that for every $1 increase in the price of the ticket, 12 less people will go. So what does that mean? Well, let's say that we increase the price by $1, so to 19, that means there's going to be 12 less people that go. So instead of 120 people, now 108 people are going to go. Okay, and that's going to give us a certain revenue amount right there. It's actually going to be different than this. Now, let's say that we increase the ticket price to $20. Then what's going to happen is 96 people are going to go. Right? For every $1 increase in price, 12 less people are going. And also vice versa. So what if we decrease the price? So let's say we decrease the price to 17. Well, when you lower the price of something, then there's more demand for it, right? So 12 more people are going to go. We're going to go the other way now. So it's going to be 132 people that go, etc., etc., etc. So what we have to do is we need to generalize this now. So what I'm going to do is I'm actually going to introduce an x variable, and I'm going to let x equal the number of $1 increases in price, like that. And so what we can do now is we can generalize this. So we can say the current price is $18 per ticket plus the number of $1 increases in price. So that would be like x over here. And for every $1 increase in price, 12 less people are going to go. So we can make this, the quantity bracket here, be 120 minus 12x, like that. And so notice that you can try with different x values. You could plug in, like, let's say an x value of 1, meaning that we're going to increase the ticket price by $1 here. If we plug in 1 for x, we'd end up with 19. If we plug in that 1 over here, 120 minus 12 times 1 would give us that 108, which is what we had before when we did it manually, quote unquote. Right? Or if we plug in an x value of 2, we would get 20 in this bracket. And then over here, we'd have 120 minus 12 times 2, which is 24. We got to do the multiplication first. 120 minus 24 would give us 96, etc., etc. And then we could also go the opposite way. So let's say x is -1. So instead of increasing the price by $1, we're going to decrease it by 1. So then if x is -1, what would we get in this bracket? We'd have 18 minus 1, which would give us 17. And then over here, -12 times -1 would give us +12. 120 plus 12 would give us 132. Right? These are the same combinations of brackets or combinations of price of ticket and quantity or number of tickets sold that we got before. But now it's nice because we created an equation, and that's actually the answer for part A, right? This is our revenue equation over here. You could put Y as well. I'm gonna let R, let's say R is the revenue of the concert, right? So this here is the revenue function. And so what I'm going to do is I'm actually going to take this, I'll put it up here to give myself some room, and let's work with this revenue relation that we have and go into a little bit more detail, because notice that this is a quadratic here, this relation, right? It's in factored form. And so let's make a graph of this and see what is happening. So I'm actually going to do part D first, and then after the graph we can visually see what's going on, and then we can answer the other questions, get the characteristics of this relation here. So because it's in factored form, let's first find out what the intercepts are, the x-intercepts. So in this case, the way we do that, well, we plug in 0 for r, right? So we're finding the x values when the revenue is going to equal 0. And so when is that going to happen? Well, either when this bracket is equal to 0 or when this bracket is equal to 0. And so now we just have to solve for the x value. So here we'll have 120 equals 12x, divide both sides by 12. So we'll get an x value of 10. And then over here we'll get an x value of -18. So those are the x-intercepts right there. Those are the x values that would make the revenue equal to 0. And don't worry about figuring out what these mean yet in this scenario. I'm going to explain that in a sec. Let's just pretend we're not even working with a word problem, and we're just working with this quadratic over here. Just this quadratic equation or quadratic relation over here. So forget about the scenario. Just pretend that I'm asking you to graph something like this, and even if you're more comfortable, instead of an R, you could put a Y here. I'm just going to keep it as R. So we got the x-intercepts. Let's write these down. Let's keep track of 10 and -18. And because we have now the x-intercepts, what can we do? We can find out the axis of symmetry. And we know the axis of symmetry, or the x value of the vertex, is equal to what? The sum of the intercepts divided by 2. Or you could put -18 plus 10, right? 10 plus -18 or -18 plus 10. Both of those would give you -8. That's going to be divided by 2, right? Because plus minus ends up being just a minus. 10 minus 18 would give you -18, or -8 rather, and then -8 divided by 2 would give you -4. So the vertex, we know it has an x value of -4. And then if we want to figure out the corresponding y value, or the r value, in this case, we would just plug in that x value of -4 here. So we'd have 120 minus 12 times -4. Then we'll have 18 plus -4 like that. So we'd end up with 120 plus 48. And then over here, we'd end up with 18 plus -4 is like 18 minus 4, which would give us 14. Over here, this would give us 168, multiplying by 14. And what that is going to give us is 2,352, like that. So that's going to be the revenue right there when X is negative 14. So that's actually going to be the maximum revenue. But again, we're going to come back to what all of this means, what this graph is going to mean in relation to the question. Let's just keep it abstract for now. And then also, let's get the y-intercept, or actually not the y-intercept, but the r-intercept in this case. Again, if you feel comfortable, if you want to let this be y and use the variable y over here, you can do that as well. Again, I'm going to keep it at r. Now, how do we find the y-intercept or the r-intercept? Well, we plug in 0 for x. So what we would be doing is we'd be plugging in 0 right there. And so what would we get over here? We'd get 120 times 18. And notice that what does this give us? That's our current revenue, right? Because we have $18 tickets and 120 people going. And that makes sense. If we let X be 0, then we're not increasing or decreasing the price at all. We're just keeping it as is. And we know that that revenue is going to be 2,160, right? So that's going to be that right there, like that. Okay, so now we have enough information to make a graph over here, a fairly detailed graph. So let's plug in the x-intercepts first. So we got negative 18. Let's try to keep this to scale as much as possible. So negative 18, let's say that's like over here. So that's 18 units. So 10 units would maybe be like, let's say, right there. Okay, and then we also have a vertex at negative 4. Notice negative 4, that's going to be like over here, let's say. Right, in between the negative 18 and the 10. Notice that how many units is from negative 18 to negative 4? 14 units. And then from negative 4 to 10, 14 units as well. And then up here, the R value, right, this is the R axis. The R value is going to be 2,352. So let's label this negative 4, 2,352, like that. And then we also have an r-intercept. Let's say, you know what, let's draw the parabola first. So we got that, and then we got that. And so over here, that's the r-intercept, and that's going to be at 0, 2,160. And so it makes sense that this is less than that, right? Because it's lower than this value over here. And so that right there ends up being the graph of this relation. Now, a couple of things. Notice how we can't have a negative revenue, and so notice how I only stopped the graph at the intercepts. If we were just dealing with an abstract graph, this would continue to go on. But notice that that wouldn't make sense because, for example, an x value of, let's say, 20, so something much greater than 10. If we plug in 20 over here, notice that we'd have 12 times 20, or negative 12 times 20, which would give us negative 240, and then 120 minus 240 would give us negative 120. And that doesn't make sense because remember this bracket here, it represents the number of tickets sold. Okay, and you can't have a negative number of tickets sold. And then also notice that any x value to the left of negative 18, like let's say negative 20, well, if we plug in negative 20, over here we'd get something positive, but then over here, which is the ticket price, notice we'd get a negative value, and you can't have a negative ticket price. Okay, so that wouldn't make sense right there. And so the valid X values, they didn't ask for that in this question, but let's just write them. The valid X values, or the domain, that's another word that you'll see come up more in grade 11. Your teacher may or may not use that. So notice that the X values have to be between -18 and +10, like that. Okay, so let's talk about what these intercepts mean. So first off, what does this intercept mean right there? Well, notice that this here, this intercept, it represents the current revenue right there, right? As we mentioned, an X value of 0 means that we're not increasing or decreasing the price. So if we plug in 0 here, 0 here, we just get that current revenue of 18 times 120, which would be 2,160. So this intercept, this R-intercept here, represents the current revenue. Now, what do these intercepts over here represent? Well, they represent the point, or the points at which the revenue would equal 0. Okay, and let's break that down a little further. Starting with this one, notice an X value of -18. What does that mean? That means that we're decreasing the price by $18. Well, at a current price of $18, if we decrease this by $18, notice that this bracket would be 0. We'd have a ticket price of 0. And if you have a ticket price of 0, no matter how many tickets you're selling here, your revenue is going to be 0 as well. And then this other intercept is 10. So an X value of 10 means that we're increasing the price by $10. So notice this would be 28, but we're also told that for every $1 increase, 12 less people are going to go. So if we increase the price by $10, that's the limit, because then notice that no people are going to go then. Because if we plug in 10 here for this X, we'd have 12 times 10, which is 120. That means all of the people that we had going before, those were decreasing. And then once you get to an increase of $10, then no people are going to go. And so no matter what the ticket price is here, if no people are going, then you're going to get a revenue of 0. Hence why the X values have to be in between -18 and 10, right? Otherwise, you're not going to make any revenue. So these are like the limits of the X values. This X value of -18 brings the ticket price to 0. This X value of 10 brings the number of people to 0, right? So those are the limits right there. And so then we're asked, when is the revenue maximized? Well, notice we're going to get a maximum revenue at that point. And so what that means, which is it's the vertex, so notice that revenue is maximized when X is -4. Now, what does that mean? That means that the revenue is maximized when we actually decrease the ticket price by $4, so 18 minus 4. So that's revenue is maximized when X is -4. So more specifically, what that means is the ticket price is $14. And then how many people are going, or the number of tickets sold. If we plug in -4 here, we'll have -12 times -4, which would give us +48. 120 plus 40, 120 plus 48 will give us 168 tickets, right? So you got to be careful. Sometimes these questions, they'll ask you at what ticket price is the revenue maximized, or how many tickets are sold when the revenue is maximized. Sometimes they'll ask you for the maximum revenue. Okay, in this case, the maximum revenue is just the 14 times 168, or the R value of the vertex, which is 2,352. Okay, and sometimes they'll ask by how much is the current ticket price increased or decreased, then they'll ask for this value. So notice that all of these values here, there's 4 different values, relate to that maximum revenue, either the maximum revenue itself, or when the maximum revenue is happening at a price decrease of $4, which would make the ticket price 14, or the number of tickets sold to be 168. Okay, so different things that they can ask for, so just make sure you're reading the question very carefully. Right, so this is a popular type of question. We're actually going to go through this kind of question a couple of times as the course goes on, because in the future we're actually going to be dealing with factoring. So this like revenue equation, it's going to be expanded, then we're going to have to get it to this point, for example. So it will get a little bit more complex, but just in general, this is basically how it works. This is what those intercepts mean. And then the maximum, sometimes you'll get a maximum at a negative value. Usually with these kinds of questions, actually, the maximum will happen at a positive value for the most part. But sometimes it could also be negative. So instead of the price increasing, the price is decreasing in this case. All right, and that's pretty much it for the question.